Hello everyone. Welcome to the next lecture on the complex linear transformation. Today I will explain you the very beautiful concept of the inversion. Myself Dr. Harish Garg, you can follow and subscribe my YouTube channel. Now what we have discussed so far, we have learned the concept of the complex linear transformations and studied some elementary properties such as translation, rotation, magnifications and so on. You can watch these lectures at my YouTube channel. Playlist is the complex analysis. You can see we have already discussed the various examples and through the easiest method. Now, what we have learned from these lectures? The very beautiful concept we have learned is it preserves the shape. What is the meaning of the shape is whenever you have the z plane under the transformation you have the w plane. The preservation of the shape means if in the xy plane you have a triangle, fine, then in the w plane it also is a triangle. Fine, it may have increase in shape, increase in the size, but it must be the same property. On the other hand, if this is my circle, then it is also my circle in the w plane. On the other hand, if original plane is my rectangle, then in the w in plane it is also my rectangle. But the most important property is this will hold only once it is my linear. Fine. Or in other word, you can say if you have a line, if you have a line in the xy plane, then it is again the line in the w plane. Line, it may be the increasing or it may be the decreasing. If this is a circle, then again it must be in the circle. That is a circle map to the circle, line map to the line. But whenever you have a non-linear transformation, then non-linear transformation means you have w is equal to 1 over z, or you can say w is equal to z plus 1 over z, or you can say w is equal to 2z minus 3 over z plus 4, fine, or you can see w is equal to z square and so on. Whenever you have a non-linear transformation, then the line in the xy plane, this is my line, they can map in the w plane to the circle as well. So the line maps either to the line or to the circle. On the other hand, the circle either map to the line or map to the circle. Fine. So once it's a linear, then it preserves the shape. But whenever it is a non-linear, then the shape may or may not be preserved. So in this lecture, we will cover the very beautiful concept of the first part is 1 over z. This transformation is called as a reciprocal mapping. Fine. Also, this map is called as the inversion mapping. But make sure students, W is nothing but my transformation. Whatever the transformation you have taken to transform the information in the XY plane to the UV plane. Fine. So the concept is very simple. First of all, you have the equation W is equal to 1 over Z. So clearly say whenever Z is my non-zero, then you can find the one-to-one correspondence between the W and the Z. What does the meaning is? If I simply choose W is equal to R e raised to power iota theta, fine, and W I can choose is rho e raised to power iota phi, or you may choose, sorry, it is my Z, fine. If I choose Z is, or you can choose Z is x plus iota y, W is equal to u plus iota v. Then we all know we can write the Cartesian coordinates to the polar form, fine, and again I can write this number to this nature, fine. So if I substitute this value in the equation number 1, what will happen? W, which is equal to 1 over R e raised to power minus iota theta. So what does it implies? So if you equate them, rho must be 1 over R and phi is equal to minus theta. Is it okay? Fine. Now what is the meaning of that? Again, what is the meaning of that theta is? theta is the argument of the z. From this case, what is my phi? Phi is the argument of the w. What is the r? R is nothing but my absolute value, that is the modulus of the z. And what is my rho? Rho is the modulus of the w. So you can see from here, I can see the modulus of the w is 1 over modulus of the, and argument of the w is equal to minus argument of the z. Fine. So, or in graphically, if you have the z with the argument theta, then this is the value of 1 over z, and the value of this, if this number is my r, then it is my 1 over r, and this angle is my phi, and phi is nothing but my minus of theta. Okay. Now, because this is my non-linear, the shapes are changes during the during the inversion transformation. What is the meaning of that? If you have that z plane and the equation is my circle, then after the transformation they are changes into the w plane in the line. You can see this is an infinite strip. So you can see it's a non-linear circle mapped to the line. So we will discuss an 8 plus numerical example in this lecture so that you can understand the concept very well. But before that, I can say you can watch my this translation, rotation and the previous lectures to easily understand the today's and the others lectures. So let's start with the first question. I hope you can like, you can comment and subscribe my YouTube channel. So find the image of the strip. So firstly, can you draw the W plane? This is my Z plane. Fine, this is my X and this is my Y. So can you draw Y is equal to 0? This is the line of Y is 0 and this is the line of Y is equal to half. So what is the common portion? Because there lies in between them. So my reason is this shaded portion. Is it okay? Now your target is you can transform them by using the non-linear transformation. T of Z is 1 over Z. So this is my U, this is my V, and this is my W plane. And your target is to find what could be the reason, whether it's a line, whether it's a circle, whether it's a triangle, and so on. Fine. Now, if you look about this case, y is lies between 0 and 1. So your target, your first target is to find the value of the y. फाइन, इसमें y लिखा हुआ है ना, तो इसलिए आपका पहला टारगेट y को निकालना है. इज इट ओके? नाउ हाउ यू कैन फाइंड द y? इट्स वेरी सिंपल. आई कैन स्टार्ट विद द z which is x plus iota y. W is equal to u plus iota v such that w is equal to t of z. And what is the value of that t of z? It's a non-linear transformation. So I can substitute the value, that is a u plus iota v. Z is my x plus iota y. So can you find the value? I can write x plus iota y which is equal to 1 over u plus iota v. Is it okay? Now how you can solve them? I can come here. How you can solve them? I can rationalize it. U minus iota v divided by u minus iota v. So it becomes u minus iota v divided by u square plus v square. Fine. So can you equate the real component? So x will be u divided by u square plus v square and y will be imaginary component minus v over u square plus v square. I can substitute the value of the y from the calculated to the given equation. So what will happen? 0 is less than minus v over u square plus v square is less than half. Clear? Now if I choose the first two equations, then it becomes 0 is less than minus v. If I choose the second and the last equation, then minus of 2v is less than u square plus v square. What does it implies? V is my less than 0. Fine. And from this case, I can write u square plus v square plus of 2v is my greater than 0. How you can solve this part? I can add +1 on the both side. Then it becomes u square plus v plus 1 whole square is my greater than 1. And from this case, it is v is less than 0. Is it okay? Is it okay? Now this is my equation of the circle. Fine. What is the center is? The center is my 0, -1 and the radius is 1. So can you draw the graph of these regions? Now it's a look at that. It's a very simple. You can see this is my u, this is my v. Now the first case is v is my less than 0. That is a negative. This portion is my v. Fine. Now this is the equation of the circle with the center is 0, -1 and the radius is 1. So that is my equation of the circle. Now because the value is my greater than 1, that means we have to shade the portion which is exterior part. So can you shade the region which is exterior? So I can shade it. This is the portion which is outside the circle. Fine. This is the region which is outside the circle. Hence, you can see your graph in the z plane is transformed to the w plane which is lies exterior to the circle and which lies exterior to the circle and in the lower half space. Why we call as a lower? Because you can see this is portion of the below. Look at the second one. Again, find the image of the circles. So what could be your target? Your target in this case is find the value of the z. अब इसमें x और y की तरह तो नहीं ना दिया जैसे इसमें y दिया हुआ था. So it is not given as a y. So your target is to find the z. So firstly we will see x. What is the meaning of the z minus 3 iota? So whenever, that means this 3 is my radius of the circle and 3 iota is my center. So if 3 iota is the center, I can write as 0 plus 3 iota. So therefore this number is my 0, 3 iota. And how you can draw the graph? This is the equation of the circle. Fine. This is the equation of the circle with the 0, 3. Now your target is to find the region in the w plane. Again, you can see that 1 over z is my non-linear. Fine. So it may possible that the circle will map to the line. Now I can choose w is 1 over z. So can you find the value of the z? Z is my 1 over w. I can substitute the value of the z is equal to 1 over w in the given equation. Minus 3 iota is equal to 3. Now how you can solve them? There are the two methods I will explain you. The first method is I can take the LCM 1 minus 3 iota w which is equal to 3 because the modulus. Fine. Now I can take the square on the both side. So it's a 3 square also. Fine. Now what is the value of the w is u plus 3 iota. I can substitute here 1 minus 3 iota u minus 3 iota square v of whole square. This is 9 and this number is u plus iota v whole square. Now I can return this number is 1. What is the 3? It's a 3 plus minus 3 iota u of whole square is a 9 u plus iota v whole square. And we all know if you have the complex number a plus iota b, what is the value of the modulus square, which is a real square plus imaginary square. So I can solve them. A real component is 1 plus 3v plus imaginary component is minus of 3u. Similarly for this case, real component is u, imaginary component is v. Now you can open the bracket 1 plus 9v square plus 6v plus 9u square which is equal to 9u square plus 9v square. Clearly say 9v square cancel, 9u square and 9u square cancel. 1 plus 6v is equal to 0 is the required region of the graph. So can you draw the region of the So that is my u, that is my v. So that means v is equal to minus 1 over 6. So where is the graph of the v is equal to minus 1 over 6? This is the value of the v is equal to minus 1 over 6. Hence, the given circle, this equation of the circle, will transform to the line that is a vertical, that is a strip parallel to the u-axis. This is the first method. Look at the second method. Because we all know if you have the complex number z, I can return this part is z into z bar. Now you can open this 1 over w minus 3 iota. 1 over is a 3 iota is a plus of 3 iota, which is 9. Fine. Now you can open the bracket 1 over w into w bar plus 3 iota into w minus 3 iota into w bar minus 3 iota square. 3 into 3 9, 9 iota square, that means plus 9, which is equal to 9. So 9 and 9 cancel. I can take the LCM. W into w bar is LCM. So it's a 3 iota w bar minus 3 iota into w, which is 0. So if my w is u plus iota v, what is the w bar is? U minus iota v. I can substitute the value 1 plus 3 iota u minus plus 3 of v minus 3 iota u minus plus 3v is equal to 0. 3 iota u cancel, 1 plus 6v is equal to 0. That means v is equal to 1 over, v is equal to minus 1 over 6. So you can draw the graph and you can see, because it's a non-linear, so it will convert it into the strip. So that means the circle, the image of the circle is converted into the straight. Look at the another one. Again, you have the value of the y. So your target is to find the value of the y. So if you draw the graph firstly, so look at that, y is equal to 1 by 4. This is y is equal to 1 over 4. This is the value of the y is equal to half. And your target is to find the region in between them. Fine. So again, let w is equal to 1 plus u plus iota v, z is equal to x plus iota y, and w is equal to t of z. So we can start with the value. Because my target is to find the value of the y, so I can return this number is, and then I can rationalize them. Find u plus iota v. So it will be u minus iota v divided by u square plus v square. So can you equate the real and imaginary component? So x will be u over u square plus v square. Fine. And y will be minus v over. I can substitute the value of the y in the given strip. Clear? I can take the first two components and you can cross multiply them. U square plus v square is less than of minus 4v. From this side, minus of 2v is less than of u square plus v square. How you can solve them? I can see u square plus v square plus 4v is less than 0. And from this case, u square plus v square plus 2v is greater than 0. How you can solve? I can add plus 2 on the both side. In this case, I can add plus 1 on the both side. The first part becomes u square. It becomes u plus 2 whole square, which is less than of the 2. And this here is u square. V plus 1 whole square is greater than 1. Fine. Now clearly say, this is the equation of the circle. Fine. What is the center is? 0 comma minus of 2. This is the equation of the circle with the center is 0 comma minus 1. Moreover, this value is my less than, so this portion is my interior of the circle and this portion is my greater than, this part is my exterior to the circle. So can you draw the graph? U, V. What is the center is 0 minus of 2. This is my minus of 2. Fine. So if you draw the graph, this is the equation of the circle, 0 comma minus 2. Radius is my 2. In this case, center is 0 comma minus 1. This is a 0 comma minus 1. Radius is also 1. So the graph will be fine. Now you can see how you can shade them. The portion is exterior to the circle. This red portion is exterior to the circle and this portion is interior to the circle. So my graph will be, that is a contour in between them. Clear? So you can see your shaded portion is the region exterior to the first one, interior to the second. That is exterior to the circle and interior to the second. Okay, look at this another one. Again, your target is to find the value of the z from the given equation. Again, it's the equation of the circle with the center 1, radius 1. So that is the graph of the z plane, and your target is to find the region in the uv plane. So what is the value of the z we have obtained? 1 over w. I can substitute in the given equation. Fine. So again, there are the two methods to solve them. First method is I can take the LCM, is fine. Now I can scaling on the both side. I can substitute the value of the w, u minus iota v, and it is less than of u plus iota v. I can apply the property of the complex number a, that is the real component, plus imaginary part, which is less than of u square plus v square. You can open them, a square plus b square minus of 2b plus v square, which is less than of u square plus v square. Now you can cancel it, v square cancel, u square cancel. That implies u is equal to half. So can you draw the graph of the u is equal to half? Sorry, it's a greater than half. It's an inequality. This is my u, this is my v. That is the value of the u is equal to half, and because I need a greater than, so the result will be this portion. Fine. So hence the circle, the given circle, this circle will map to this side. Fine, because this is my nonlinear transformation. Fine. So the circle may not map to the circle, so it's mapped to the line. Second method, you can use the property. So I can open them. This number is 1 over w minus 1. This number is 1 over w, because it's a real component, so it's the same. Fine. Now you can open the bracket. It is 1 over w into w bar minus 1 over w minus 1 over w bar plus 1, which is less than equal to 1. 1 and 1 will be cancelled. Take the LCM of the w into w bar. 1 minus w bar minus w is less than 0. So if you have a w is u plus iota v, what is the complex conjugate is u minus iota v. You can substitute there. It's a minus u minus minus plus iota v minus of u minus of iota v. So iota v will be cancelled out. So 1 minus 2u is equal to 0. Again, that give you u is equal to half is the right answer. Fine. Sorry, again, it is not the equality, it's a less than sign. Fine. So it will be u is greater than equal to half. So you can draw it. That means the closed disk is mapped to the right half of the disk. Fine. So right half of the line, u is equal to half in the w plane. Look at the next one. So in this case, the equation is given as y minus x plus 1. So what is your target? Your target is to find the value of the x and the value of the y from the given transformation. So you can choose w is equal to u plus iota v, z is equal to x plus iota y, such that w is equal to t of z, and t of z is my 1 over. I can substitute the value u plus iota v, which is x plus iota y. Fine. I can find the value of x. So I can multiply with the u minus iota v over u minus iota v, which implies u minus iota v divided by u plus iota square. So what is the value of the x? X will be u over u square plus v square. Y is equal to minus v over u square plus v square. Always remember students, the similar kind of the questions I already explained in our previous lectures as well. Fine, you can follow this complex analysis playlist. I can substitute the value of the x and y in my given equation of the line. Now you can take the LCM. This number is minus v minus of u plus u square plus v square is equal to 0. Fine. I can make the pair u square minus of u and v square minus of v, which is equal to 0. Then you can completing the square. I can add 1 over 4. I can add 1 over 4. So I can add 1 over 4 on this side. The left hand side becomes u minus half whole square. It's a v minus half whole square, and this number is 1 over 2. And clearly say this is the equation of the circle. This is the equation of the circle. What is the center is? Half comma half is my center. And what is the radius? So radius you can obtain from this case is 1 over root 2. So can you draw the graph? So this is the equation of the circle, u and v. Center is my half comma half. This is the half, this is the half, this is my half comma half. You can draw the circle of radius 1 by root 2. Look at the next question. Now your target is to find the value of the z. Fine. Again, firstly you can draw the semicircles. Radius is my 2, angle is my 0, and this angle is my pi. Fine. So I can start from the w is equal to t of z. Is it okay? Now z is equal to 1 over w. I can substitute the value in the given equation. The first one is, so if you substitute them, it is 1 over, which is equal to 2. That implies w is equal to 1 over 2. For the second case, 0 is less than of argument z. Okay, I can write for you 0. What is the value of the z? Is a 1 over w, which is less than of the pi. And we all know what is the argument of a over b. It is argument of a minus argument of b. So I can write 0 less than equal to argument of 1 minus argument of w is less than equal to pi. And for any complex number x plus iota y, how you define the argument of z, which is equal to tan inverse of y over x, and clearly say how you can write the 1. 1 is 1 plus iota 0. So what is the argument of the 1? That is tan inverse y, that is the imaginary part, 0 over 1, which is 0. So therefore argument of 1 is my 0. It's a minus argument of w, which is less than pi. So I can multiply both sides by negative. So it's a minus pi less than of argument of w is less than equal to 0. Fine. Now look at that. Absolute value is half. So this is my 2. So here is somewhere is half, and this number is my minus half. Angle is my minus pi. If this is my pi, angle is minus pi at this side, and 0. So it's a from. Fine. So that is the graph of, this is the graph of the z is equal to 1 over w, or t of z is 1 over z. So that means the argument is half, and again is a semicircle. It is also the semicircle. Both are semicircle, but it's an inverted semicircle. Fine. So the image after the reflection by the reciprocal mapping is half minus pi to 0. Okay, look at this another one. Find the image of the vertical strip. This is my x. This is my y. X is equal to 1. Fine. So it means your target is to find the value of the x. So again, the similar way, I can start with this u plus iota v. I can multiply them, u minus iota v, u plus iota v. So if you equate the real component, u will be u square plus v square, and y will be minus v over u square plus v square. I can substitute the value of the x in the given equation. Fine. So that will be x is equal to, is it okay? Now, first of all, clearly say u is my non-zero. Why? Because if u is equal to 0, then 1 is equal to 0 is not possible. But can v will be the 0? Yes, v can be 0, because if v is equal to 0, I can choose u is equal to 1, then the equation will be satisfied. The only condition is u is my non-zero. Now can you solve this equation? So u square plus v square is equal to u. Fine. How you can solve them? I can add 1 over 4 on the both side. Clear? The left hand equation becomes u minus half whole square plus v square is 1 over 4. This is the equation of the circle with the center half. This is the equation of the circle. What is the center? Center is half comma 0 and radius is half. So this is my half comma 0, radius is my half. So that's the equation of the circle. So that means this is the value of the w is equal to 1 over z. But make sure make sure the u is my non-zero. So this portion is my not in the image. If I magnify them, the graph for you, you can see. Fine. If you look about that, the value, this is the open circle, this is the open point, because u is my non-zero, so this is my open point. Fine. Okay. Or you can write, because this is the equation of the circle, so I can write this number is w minus center is equal to radius. So what is the radius of the circle is 1 by 2. Fine. Center is half comma 0. So how you can write half comma 0? Half plus iota into 0. That number is my half. So now look at, these are the 10 exercise examples are exercise for you. I hope you have understand this lecture very well. You can solve these questions and let me know your answers in the comment box. I'm waiting for your comments so that I can understand that you really understand this lecture very well. We will see the next lecture very soon on the Morbius transformation. That's a very important topic on the complex analysis. Till then, you can share this video, you can like and comment on this video as well. Happy learning always, students. Best wishes. Thank you very much.